Good morning, students. Today in this session, let us discuss the last concept of Unit 3, that is utility theory. What is this utility theory? Utility theory in AI is a mathematical model framework used to model decision making under uncertainty. So whenever we want to make some decisions under uncertainty, then we can make use of this utility theory as a decision making process. It allows us to assign subjective values or preferences to different outcomes and helps to make optimal choices based on these values. Utility theory is widely used in various applications like game theory, economics, robotics, and recommendation systems, among others. And this, coming to the concept of this utility, it is subjective and varies from person to person or from system to system. It represents the degree of satisfaction associated with different outcomes. For example, there are two main examples for this utility theory. One is a recommendation system and other one is a robotic application. In recommendation system, the utility could describe the level of user satisfaction with a particular recommendation. And when coming to the robotics application, a utility could represent the cost or risk of different actions. And it also provides a way to model decisions in uncertain or probabilistic environments, okay, where the outcomes are associated with the different probabilities. Okay, when we have to make some decisions to a model which we are uncertain or probabilistic environments, then this decision theory will come with some outcomes which are associated with different probabilities. Next, utility function. A utility function is nothing but a mathematical function used in AI to represent a system preferences or objectives. And it assigns a numerical value which generally we refer to it as utility to different outcomes based on the satisfaction level. And it is a quantitative measure of the system's subjective preferences. And it guides us for decision making in AI systems. And an agent or system typically defines the utility function based on its goals, objectives, and preferences. It maps different outcomes to their corresponding utility values, where higher utility values represent more desirable outcomes. And coming to this utility function representation, generally we represent it as U. This is the representation of utility function, and it is mathematical function that takes as input the different features of an outcome. The input may be different features of an outcome and maps them to a real valued utility value. Okay? And we can represent this utility function mathematically as U of x. This is the representation, and for a particular utility function we are going to represent it as U of x, where x represents the attributes or features of an outcome. And how we define this utility function can vary depending upon the application and the type of the decision problem we are trying to solve. It varies from one application to the other application. And one more important concept in this utility theory is decision making. For decision making only, generally we are going to use this utility theory. One common approach in the AI decision making is to maximize the expected utility, which considers the probability of different outcomes occurring. And this expected utility is calculated by multiplying the utility of each outcome by its corresponding probability and then summing up the results. And this AI system chooses the action with the highest expected utility as the optimal choice. What is the optimal choice or optimal solution is the action with the highest expected utility will be the optimal choice for this decision making AI system. And then let us see the two examples of this utility theory. One is the self-driving cars. So if we consider the self-driving car application, what do you think the utility function may be? That means we can consider for a self-driving cars factors such as time taken, fuel consumption, safety and comfort, and these are some of the factors we are going to consider as a utilities. And we are going to assign different utility values to different routes based on these factors. So the self-driving car can use these utility values, whatever we have assigned, to calculate the expected utility of each route, taking into account the probabilities of different traffic conditions and obstacles on the road, and choose the route which is going to give us the highest expected utility to reach the destination. That is what an example of self-driving car. Similarly, let us discuss one more example, that is recommendation system. Consider a recommendation system that suggests movies to users based on their preferences. Maybe the utility function recommendation system may assign higher utility value to movies that match the user's preferred genre. That means what type of category particular person is liking the movie, actors or directors, and some lower utility value to films that do not match these preferences. Means if a particular person is matching with this, we are giving the higher utility. If it does not match, we are going to give the lower utility. So then the recommendation system can then use these utility values to rank and recommend movies to the user based on their utility values. Whichever having high, that they will prefer, give more importance. Which are having less, they are not going to recommend that. Okay, so these are the two best examples how we are going to make use of this utility theory in decision making. Next, utility theory. In AI, this utility theory provides a formal framework for reasoning about decision making under uncertainty. So it is often used in this AI system to model decision making in situations where outcomes are uncertain or probabilistic, and this AI system needs to make choices based on its preferences or subjective values. Suppose let us discuss one example, lottery. To understand the concept of this utility theory, let's consider a simple example of a lottery. Suppose you are given the option to play a lottery with two choices. One is a guaranteed prize of $100, a 50% chance of winning $200, and a 50% chance of winning nothing. So now you have to make the choice. So which option would you like to choose when we have such situation? So your decision depends on your risk tolerance, financial situation, and personal preferences. Maybe any one of the reason may result the option which you choose. So utility, in that case, this utility theory provides us a way to model and quantify these preferences mathematically using a utility function. So let us see the notation of this particular utility function. That is, let x represents the outcome or an option for a particular problem, and this u of x denote the utility function which maps x to its utility value, and let P of x denote the probability of outcome of this x occurring, and let E of u of x denote the expected utility of outcome x. Just try to understand, x is the outcome, u of x is the utility function, P of x the probability of an outcome of x occurring, and let this E of u of x denote the expected utility of outcome x, which is the sum of the utility values of all possible outcome weighted by their respective probabilities. So that is calculated, this u of x is calculated using this expression, E of u of x equal to sigma I P of xi into u of xi. That means in this formula, this u of x represents, we know that it is the expected utility of a decision or action, and which is the sum of the product of the probability of each outcome, that is xi denoted as P of xi, and its corresponding utility value which is denoted as u of xi. Okay, this is how we are going to find out the expected utility of a particular problem, and the summation is taken over all possible outcomes I. In this way, when you have some uncertain or probabilistic reasoning problems, and when you are unable to take some decisions, then you can make use of this utility theory as a decision making system in artificial intelligence. Thank you.